There is a chart management toolbar in the CES EduPack software. It sort of looks like this, and it is on the top right half of your screen typically. I've enlarged it for your purpose. You are looking specifically at this particular kind of icon, which is a line selection tool. You can enter, when you click on it, you can enter the slope of the line, and in this case, if it's 2, then you are basically looking for this particular material index, and that is the slope 2, and you can basically move this around with the same slope for different values of capital M, the material index, which is determined by the design situation. So you can go up and down depending on the different values of M. So for instance, you will see that in the category of metals, to be able to get minimum mass designs in the family of metals, aluminum alloys and magnesium alloys end up being the best alternatives and are used routinely for aerospace, for instance. Carbon fiber reinforced plastics also fall well into this category, and so they also get, and they are even better than the aluminum and magnesium alloys, and so can be used in a lot of specialty aerospace structures. These are some of the ways in which the group of materials got selected for aerospace related applications. You can see all the different materials that got eliminated from consideration based on this material index alone in the Young's modulus versus density plots. So based on this criteria, all the ones below were eliminated and only ones in the top get retained. So wood parallel to the grain ends up still being quite a good option among natural materials. Bamboo also ends up being useful. The nature of the slope also has to do with, if you look at variations, you will see the longitudinal wave speed for E, which is parallel E over rho material index. These materials tend to alternatively get eliminated from 22 options to fewer options depending upon other considerations, right? So if you had only one objective, maximize E raised to half by rho, then you go to this plot as we just saw and eliminate the ones below this line and keep the options above this line, 22 odd options. Alternatively, you would have additional criteria as well. So you want to maximize E so that you end up avoiding buckling, and so that eliminates these possibilities, and so you have only these different options over here. Ceramic legs. You could also say that it should take a minimum modulus of 10 gigapascals. That's another way to specify how to be able to get rid of additional possibilities and just look at options over here. So fiber reinforced plastics end up becoming extremely good options for light and stiff materials for table legs. Those were examples of bubble charts that we've seen in CES EduPack. Alternatively, bar charts is another way to represent options. Normally, a single material is plotted on the y-axis, and then various possibilities can be used. CES EduPack allows you to use combinations and plot material indices as well, rather than just individual material properties. And so, if you are able to then plot this E power raised half divided by rho material index, you can, depending upon the criterion of this value, group over these possibilities in a bar chart and come up with carbon fiber reinforced plastics or magnesium alloy and aluminum alloys as major possibilities, with titanium alloys being at the edge of the box, for instance, in a similar identical manner. How do you get to this? Right? So for that, you end up using within EduPack the select tool, and you can then choose graph, and for X or Y axis, in this case Y axis, you can choose advanced, and here you can use the properties. You can click on them and then combine them into equations. For instance, modulus to the power 0.5 divided, and so you put another bracket and then divided by density. You just click all these, and that's how you end up getting that bar chart. to obtain that particular material index. It will be useful for you to practice how to get bar charts for these other indices such as e to the power 1 over 3 divided by rho and e over rho as well, and begin to use them for material selection. That will be part of the exercise that you would do in order to gain familiarity of material indices and their use in material selection, and using CES EduPack as a way to perform material selection using the 4 steps of function, objective, constraints, and free variables. In the next class, we will continue the conversation of material selection, which is from chapter 6 in your book, based on a number of case studies.